It's a bridge we need between user and the developer. You are the developer. You must know your customer. Okay. So without knowing the customer, you cannot create a new product. So that's why we need a support of a developer to support the customer. So fine. So the book you are following is Alexander Kosikov and William, Principle and Practices, System Engineering. So this is the first textbook. And we are having class in professional web page on Google Class. Code is RTSRWJI. Okay. This is a web page. You can join. Okay. So already we have conducted polling activity. I hope you remember our subject code, faculty name, everything. Okay. So let us go into the. We have done with maximum groundwork. So and we have tried a trial and error method also. Good going. I hope all are comfortable in this online platform. Okay. So what is a system? Okay. So everybody knows this system is a set of interrelated components working together toward some common objective. To want to achieve something, ATM is a system. The bus is a system. Your watch also have system, and our government also have some system. A system should be followed to achieve some goal or some common objective. It's an interrelated connection between people, and when you go to the machine, we say it is components. All the components is working together towards some objective. Okay, so that's why we need a set of people, integrated people. Yes, we used to say it is a composite of people, and around the development of products and process to provide the capability of satisfy a stated need or objective. We have achieved the objective. Suppose I want to develop a Android phone. First, I need a Android programmer. Android programmer can develop Android apps. So then only people will use that mobile. We need support of applications as well. We need operating system. That's why it is called as collection of different elements. In fact, to produce result that are not obtainable by elements alone. Not only elements, we need components, interconnections, functions, materials, product, users. Okay, everything is involved. Okay, so a system can be a natural or engineering. For example, in nature, you can say it's a solar system. It is a complete nature. God created that. You see, never any planets are meeting with accidents. Of course, in our Earth, we are many people are met with different accidents, but the Earth and Jupiter and Mars never met with accident. Okay? Because it is a system. It is a natural system. It is revolving in its orbit. Okay, the sun is rotating, Earth is moving, even other planets also moving, total galaxy also moving, but everything in its position. So that is called as a system, a solar system. Okay. Sun will be in center core, and all other planets will be moving around the sun, but they never met. They never meet also in future until the galaxy don't completely destroyed. Okay. It will work like that only. Okay. So that's why how the natural system is related to the artificial system, AI, artificial intelligence. So take example, wireless telephone network, power generation plants, and our highways. These are engineered, created by engineer. Okay. How these products are developed based upon the feedback is a mechanism to compare the goals and outputs. Okay. So they will collect the feedback from the people, those who are using the system. So based upon that, they will go for new versions, version 1, 2, 3, 4. Okay. They will reduce the errors, they will go for new versions. And apart from that, there are two major concepts behind the system. So one is non-complex and always a complex system. So what is complex? What is non-complex? A complex is an engineering system involves many engineering disciplines. For example, weather satellite system, air traffic control system, weather forecasting system, okay, railway reservation system, railway track control system, okay, and traffic monitoring, trafficking system. Okay. So these are very complex system which need many disciplines: civil engineering, computer science engineering, information technology, and E&I, mechanical engineering. So these all people are connected to create a complex system. What is about not complex, which doesn't involve any multiple disciplines. Okay. So only one discipline: washing machine, refrigerator, dishwasher, and vacuum cleaner. It doesn't need any support. Washing machine doesn't need a support of a computer science engineer. And refrigerator also doesn't need a support of a mechanical engineer. These are non-complex. Okay, it doesn't involve not much, one or two. That is enough. Okay, so got it. So this is the elements of system. So in this diagram, you can easily understand what are the elements of the system. So very simple. So what computer does: central processing unit, memory unit, control unit, arithmetic logic unit, input unit, output unit. That's it. CPU with input and output. Same thing. A system with input and output. Very important thing is the process. How it processing, how it is executing, how it is transmitting, how it is delivering. For example, take this is assume that this is ATM machine. So input output always connected. When you insert the card is the input. Output you will get it as a monitor. Please enter your PIN. How you are seeing in monitor? Because processor, and the process is connected with the system. Centralized system, maybe banking system in ATM machine. If we go for railway reservation, that is different. That is connected to the railway reservation system. If you take bank, the banking having the database in the ATM machine, how much you can take based upon the amount available, money available in ATM also. Okay, so that is the concept behind the system. System engineering is totally about process and the way it is connected to the interrelated components. These interrelated components, that means multiple components, multiple product, multiple elements connected with the help of process. So where you can give input and take out. Whatever you want, just give input and you will get the output based upon the user request. So what is system engineering? Fine, it's a very interesting concept. You must remember how it is always being used in real time. So multiple tasks are involved when you take a weather forecasting system or a railway reservation system or a banking system. The multiple decisions are taken based upon the multiple standards available in different products and development available in the market. For example, we can say it is EIA 632 standard system engineering according to 1994. Okay, so they are telling that it's an integrated and life cycle balanced set of system, people, products, process, solutions that satisfy customer need. So one explanation. So on another standard, MIL STD 499A, so engineering management. What they are saying is, so decision transformation and logical sequence, which is leads to a system performance parameter, preferred system configuration. This is two different terms and definitions, but both are related to the system engineering. So coming to the IEEE standard, what they are telling, what is system engineering. If you ask to the IEEE, so what they are telling. So they are simply explaining it is completely interdisciplinary, collaborative approach to derive, evolve, and verify a life cycle balance system solution which satisfy customer expectations. So what is the customer expectation? That is a beautiful and the holistic way of delivering the information between the developer and user. That is a very important term, customer expectation. And meet public acceptability. How public is accepting. The acceptability is having a huge, and it is one of the big word. The public have to accept the system is coming into the market. The students were asked to pay the fees immediately. If I don't have money, how can I pay the fees? So public cannot accept the system how to change. So we will get time up to September 20 or something like that. So this is a standard is completely acceptable by the people and public. So that is very important and useful definition from IEEE P1220 during September 1994. So this is a complete architecture and design or system design for system engineering. Look closely into this diagram, you can able to learn a complete concept behind the video which we watched at the beginning of the class. Engineer is trying to take breakfast in a different way, but how he does it, how he achieved it, based upon multiple interconnected, interrelated components. So many components. You saw mobile phone, the baby just pushing, and laptop is fell down, and again some more components are coming into the picture. Finally, he got his breakfast on his table. So it's a simple and complex, and more complex to take his breakfast. How complex it is to make the system to do work in a coordination way. We need coordination also. So that is called as the bridge. You can see the bridge here. Okay, system engineering is a bridge. And concepts, principle, and practices. Whatever he have the concept, he have the principle, and he have practiced many times. Okay. So that bridge will help the user to connect with system developer. The system developer, I am the developer. I know software engineering, I know C, I know Java, I know hardware, I know networking issues, I know how to connect my computer with Wi-Fi, everything I know. But the user is my customer. He will come to me. So he will ask me to develop a railway reservation system for Indian government. The government is maybe user, or a private company may be a user, or maybe a private corporation, maybe a customer. Customers will be in any form, or local small industry like textile industry or automobile industry. So any industry person will come to me to solve some problem. He may ask to solve some problem, and he may ask to do in smart way. Okay. So the customer, user, and I am the developer. How the solution is given from developer is only with concepts. If I know concept, if I know principle, if I know practice, I will construct this bridge. How I should know how to construct the bridge. If I don't know the concept of this, how to construct the bridge, then I cannot give the assurance to the customer what I will deliver to him. I need good people from my side to deliver the product to the end user. The end user always check for operational need requirements to run his automobile industry, to run his bank, to run his railway reservation system on online, or maybe Amazon or Flipkart online shopping software developed by some XY. or maybe a Google. Okay, so they will be giving solution to the customers. So this is a ultimate concept behind how we are going to fill the gap from user needs to system development. That is bridging the gap from user needs to system development. Very simple, very easy subject. Only thing you have to read it every day. Please read it. So the book and material is available in the Google Class. So please read it every day. Definitely you can score more than 95. Okay, if you read 5 minutes per day, definitely you will get more than 95 out of 100. You can score more than 95. It is a scoring subject and one of the very easy subject, but lot of concepts are there and very interesting and very important for you as a computer science system engineering student. This subject is more important, and it is going to play vital role in future. If you go for MNC, in future you are going to become developer. You must know this subject, this course. This course will give complete guidance about how you are going to work with the customers, right? So please listen carefully. So what is traditional engineering discipline? Okay. Traditional engineering is nothing. It's totally focused on its total operation. Okay. So when you go 1960s, 70s, mechanical, electrical, and other engineering, they have their own standards. Only they will focus on their operation only. They never come to computer science. Computer science is separate, mechanical is separate, electrical is totally different. But now scenario is different. Okay, now the latest engineering is different. Traditional engineering is different. Okay. So the traditional engineering follows the standalone concept, but the latest engineering concept is only project. Okay, everything is a project, so and multidisciplinary. Such enterprise is called project and directed by the project manager, aided by the staff. So now we all are working the concept that is called as project. So in company also, if you join, they will put you in project. You have to do some work and deliver the product to the customer. The project may be in any form. You have to develop a software, you have to develop a product, or you have to find something, some solution for the enterprise. Okay. So this is the first topic, the references from. So again, Williams, Alexander Williams, System Engineering, chapter 1, page number 3 to 5. You can find this in first chapter. It's what we are having. So based upon that, we'll have the origin. Okay, so the origin was very old. So if you start think about for example, pyramid in Egypt or temples being constructed by our emperors. Okay, so take Rajaraja Cholan or somebody. So that time, if we talk about the temples, big temple in Tanjavur. Okay, so around the 3,000, 5,000 years ago. Okay, Angkor temple. How they constructed. Okay, so even they don't have any machines. So only humans and animals they used for constructing big temples. Okay, and big constructions was in Egypt also. One of the best example. Okay, so there is no particular evidence. Okay, till date. Okay, the Bible records that no ark was built to a system specification, and there is no particular date can be associated with the origin of system engineering. We don't know when it is started really. So when the engineering started, we don't know, but officially we have recognized. So during 1950s and 1960s, during World War II, okay, so we got some systems including internet what we are using nowadays, that also origin during 1950s and 16 during the World War II. So the way they started using the advancement technology like internet, intranet, okay, Wi-Fi, so these Bluetooth. Okay. So those concepts are started slowly evolving. Okay, particularly they used only in military for a defense purpose. Okay, so performance aircrafts, military, and proximity fuse, and German V1, V2 missiles. Okay, especially atomic bomb. Okay, so those are some of the advanced where American dropped the fat boy in Hiroshima and Nagasaki. Okay, so these are the advancement during 1950s and 60s. So we can consider origin of system engineering. It's very old, so but officially we can consider 1950s and 1960s. Okay. And also it focus on new approach and programming, planning, technical coordination, and engineering management as well. So particularly the defense, military, Russian and Germany, so Hitler, so during that period, so they started using this kind of engineering system. Okay. Later it is started using in the markets for business. Okay. Then MNCs came, multinational corporations are there. These people started doing business. So those who whenever we used this technology in World War II, so those technology, whatever we are using now, it's become business, including your mobile phone. So during 1917 60s, it was around 3 lakhs. It will take 3 lakhs to create one mobile phone. So there is cordless, wireless phone. Okay. That was big size. Now we are using it the same thing in small size. So all are solid state electronics, perhaps a more profound effect on technology growth. And what we have to understand the relations between the different eras. We have Stone Age, Ice Age, okay, but now we are living in information age. Okay. So digital age. Okay. Now everything is become digital. There is no more information. Okay. Now we are living in digital world, digital age. Okay. Everything become digital. So we have advanced technology and competition, and we have specialized people on that. So this is all about origin. So origin is very simple. There is no evidence when the engineering started. So the big kingdoms started to rule the world. They started. Very good example is temples in India and Angkor Wat and Egypt. So these are the very good example for marvelous engineering 5,000 years ago. Okay. But officially we can say it is 1950s people started using this kind of technology. So the technology behind that is called as system engineering process. How the people are started using the technology, okay, without any so there was an network issue again. It's not a problem. Okay, so we joined again. Fine. So origins of system where we are discussing about this. Okay, how we have the problems with the technology. Okay, so even though we have advanced technology, okay, how we have the solution for the competition happening around the world. Okay. So that is being one of the major trend among the different people in the market. Okay, so where we have much to learn in the system engineering. So fine. So so next topic we'll go for the examples. Some of the examples in system engineering. So the general example, day-to-day life, you can say anything. Anything you are using is a very good example for a system engineering. Okay, so refrigerator, micro oven, dishwasher, vacuum cleaner, radio, all perform the number of useful operation in a systematic manner. So everything have some system. Okay? And all the home appliances as well, engineering, your car, your bike. Okay, everything need a support of, okay, system engineering. Okay, engineering play the vital role everywhere. Perhaps we have good engineers, we have some of the strategy to create multiple technology across the globe. Okay. So some of the characteristics is required for being a good engineer as well engineering product. So it satisfies the specified need, and it should be a multidisciplinary, and it must use advanced latest technology. These are the major characteristics of system engineering. So very good example you can see in this diagram, where you can able to closely check. So what are the complex systems, okay, in signal and data. Particularly in signal and data, we have many complex system, but we'll take around 5 for example. So one is a weather satellite and terminal air traffic control system, track location system, and airline reservation system, clinical information system. So these are some of the complex system which need multidisciplinary activities. Without this, so nothing cannot be done. Okay. For weather forecast, we cannot use a single technology. We need multiple technology. Similarly, for airline reservation also, we need to involve multidisciplinary people, okay, and interdisciplinary also. What is the input for a weather satellite? Definitely image. So the process we are doing for a weather satellite is data storage. We have to store the image and we have to transmit the image. So that is called encoded image. The air traffic control system, we have air beacon responses, identification and tracking to identify and air tracks and communication. So these are the major outputs of air traffic control system. The flight is on the air. How it will be landed. So based upon identity, tracks and communication. Communication is very important for an air traffic control system. And location system, cargo routing request. These are another concept behind how it is evolved in the period of time, how it is being used for multiple purpose. So cargo routing, so all the trucks, they started delivery the product of the company, it will be monitored 24/7. So map tracing, communication, and deliver the cargo. The airline reservation input is travel request. I am requesting for to travel from Mumbai to Chennai or somewhere. So they will manage the data and reservation is done. I will get the tickets. Okay. These are the outputs. Finally, health doctors, they will create patient ID, test record, diagnosis, processes, they maintain the information, patient status, history, treatment, finally. So these are the steps involved for a complex system, example of a complex engineering system. Okay. And another example we'll consider is modern automobile. Modern automobile is more complex vehicular system, okay, and they involve multidisciplinary, different disciplines. Okay. And also we have to maintain the close control between engine emission and sensors and fuel injection and particularly air. Okay. So these are the some of the major concept behind in automobile. What people are expecting is anti-lock braking system. Okay. So another example is we have finely tuned automatic automobile subsystems. Okay. So everything become automatic. Okay. We no need to manually operate. So now because of AI, it understand you. The system is trying to understand the human, and it will act like human, and it's think like human. Okay. So that's why we are in the world of AI based smart cars. Okay. And modern automobile always have the cost. Okay. and reliability, performance, comfort, safety. A number of other subsystems are involved in creating a car or any vehicle. So that is a very good example for system engineering, complex system, and automobile. So day-to-day life, what we are using, everything is based upon system engineering. Okay. So how can you use your knowledge, whatever you have learned for the past 3 years, and you are in final year? Okay. How? What are the jobs? How can you use this knowledge for a career purpose? Become a successful computer science system engineering. You must know how to solve the problem, and you must enjoy the learning. Okay, and you must ready to face any challenge, and also we have to look after unproven assertions. Okay, and open-minded to new ideas. Definitely, if you are going to work in a company, you should be open-minded and ready to give some new ideas to the company. Okay, the company is expecting from you is ideas, new ideas, and you should be strong as a system engineer, computer science system engineer, CSSC student. You must be strong in solid background science and engineering, both science and engineering. Okay. And you must have demonstrate the technical achievement in specialty area, which area you want to do what, whether you want to become a data science scientist, or you want to become network engineer, or you want to become a Java developer. Okay. You should demonstrate. Okay. You should do the better project. Okay. Your project only speak. Okay. So start do your project. So identify the title. Okay. So you have to prove what the project you have done. Okay. And not only in CSSC, you must have idea about several engineering areas. You must have touch with ECE, civil, mechanical, and triple E, E&I. So all these streams you must have some touch, fine touch, and try to pick up new ideas and information quickly. Whatever, learn more, so read more items, know more content from online, and try to develop your knowledge. Okay. So not only knowledge, it's very important for a system engineer. Very good communication skill as well intrapersonal. So perhaps you have some good knowledge, okay? But at the same time, you must have communication skill also. Okay? That is very important for you. And apart from that, some of the engineer must have the four more qualities. So the main quality is, as a system engineer, you must seek assignment to the problem. Very challenging, not as easy problem. You have to take challenging problem in your domain. And whatever I'm giving a lot of work and assignment to you, whatever the work assignment giving to you, it should be completed in time. Discipline. Okay. So discipline is very important for an system engineer. I think our assignment has been submitted by only two. So another 2% have submitted. Okay. So please, whatever the assignment is there, try to do complete. Okay. In not only just for name sake, you have to do very deeply. Understanding in big picture is also essential. You must have good clarity across the idea you are working. Okay. And also, being a system engineer, you must manage many activities at the same time. You have to attend seminar, you have to attend a conference, you have to listen class, you have to submit the assignment, you have to do project. Okay. So that is called multiplexing. Then only you can survive in the MNCs. If you want to survive, you should be a multiplexing, okay? Not like a normal person. Okay? You can able to manage multitasking. Okay? So please start do that. Okay. attend seminars, workshop, participate in events, okay, hackathons, attend the quiz, okay, attend the develop, create a project, and attend the project-based events. Okay. So these are, and last one is, as a system engineer, should not be scared of complex problem. You should not run away. Any complex problem is given to you in future, you should ready to face that, and you must cope up with the working environment. Maybe you don't like the environment, you should join and work in team. So that is a vital role of a system engineer. So you should have some strategy to run your ideas and get the idea done. Okay. So that's what the company will expect from you. So these are other four qualities for a system engineer. Okay. So you can see the big picture of how a system engineer is being used for multiple purpose. How the idea behind that people are being used by system engineering development model. Okay. How can we use, so assign challenging problems, okay, and exposures to the big picture, okay, right, and ability to multiplex, right, and proclivity for complexity. Okay, so ready to face the complex problem and more proactive, okay, to find the solution for the problems. Okay. So these are the things expected from the system engineer. If you want to be a good system engineer, okay, you must have these four carrier elements being used by the person, the system engineer. Will have the quality work experience, exposure, proactive, challenges, and multitasking. So please remember, these are the very good career development activities for a system engineer. This is a model. So from today onwards, you can start, learn, and start do these activities. You try to get some training, attend training programs, and start think about new ideas and get work experience also. You can start with work with small project, internship. You can apply for internship. So in training programs, what you can learn. So APSSD, they are conducting many training events for the student. Please participate. Okay. So principles, tools, and case studies. So everything is focus is on leadership. In training, you must get leadership knowledge, how to become a leader, and what you can able to think, multitasking, problem solving, complex problem solving, and experience, internship. There also you will get multitasking, how to solve the problem, but everything based upon MNCs, a company, product oriented. So this is a big picture about how a person can become a good system engineer, a computer science system engineer. You must be careful about these three. Okay, you need training, you need deep thinking, and you need work experience also, right? Uh, and this is another T model. So this is called as T model for a system engineering career development. Okay, so chemical engineering, mechanical engineering, and electrical engineering, aeronautic engineering, app math, applied mathematics. So everything is involved. You can see in this big picture. So one is breadth. So you should have breadth on domain knowledge. And another part is we have different educational disciplines, multidisciplinary. Okay. And left side you can see experience, how much experience you are having in C, C++, Java, or any kind of work experience you are having And right hand side you can see it's a mentoring. Okay. So how you can mentor? So first you can contribute as a technical person. If you start work in a company, then next level you will be going as a team player, project leader, team member. Next level you will become system engineering. It will take 9 to 12 years. Okay. And next level is senior system engineering. It's a level of whole the company project leader. Okay. And the top level is CEO. Okay, a system engineer leader. So you must have 20 years of experience, as well the knowledge, deep knowledge about the particular concept. One day you will become like a Google CEO or Facebook CEO or somebody. Okay. So to become that, play that role, you must be a good technical contributor and team player and good system engineer and senior project manager. Finally, you can achieve CEO, Chief Executive Officer. So it will take 20 years to achieve that position. Okay. So education, what do you need? Any kind of engineering degree? Maybe you need UG as well. You can do for PGME as well. You can try for PhD, doctorate. Okay. So doctorates of philosophy or doctorate of science. Okay. DSI. So DSE or anything. You can do PhD, either DSE. Okay. So everything is available for you, and it will be giving work for you. So you must have the domain breadth knowledge, as well you need qualification, as well you need experience and mentoring. So this is called as T model. Finally, it will end with a small project leader or large project leader or program leader or a system program leader. So in this diagram you can able to understand, if you complete CSSC degree, BTech degree, then what is your future? This is your future. You can do MS, you can do PhD, you can do Doctor of Science, and you can become a CEO after 20 years. From 2022 to 2040, so you will be in a good position. Okay. So these are the main idea behind how career development model for a 56 number. That's great. And complex engineering system, modern automobile. So these are things we have discussed in the last week. And career also. If you study system engineering, so what kind of job is waiting for you, and how can you can develop. Okay. So very important thing is ability to multiplex. Okay. So multitasking is one of the major uh, principle, or it's a major skill you required. The skill, very important skill you required is that is called as T model. Okay. T model, you should have experience, you should have education, and you should have the mentoring concept. Okay. From today, in the next 20 years, you will become CEO of some company if you follow the domain breadth and education discipline which you are having. So then next concept we are going to discuss today is perspective of system engineering. So the very important perspective is system thinking approach. So you must understand the environment, process, and policy of a system problem, and you have the knowledge of examine the domain, okay, in the way of quantitative terms, okay. And everyone should have the idea, all the system engineering students and engineers, okay, to have the knowledge to define the problem. What is the problem of living in Mars, and how can we come up with a solution, and how can we construct a building or a home in the Mars, yeah, other planets. Okay. Out of this earth, how can we take the things to that transportation? Another important thing is transportation. So the problem you have to define, and finally you will get the solution. If you can't address the problem, it is difficult to get the solution. Okay. So that's why it can be used wisely in secondary school, and young students get knowledge of big picture as they learn fundamental science and engineering skills. Definitely, so every school and college should discuss more about the system thinking concepts. So one of the first perspective of system engineering is thinking. You must have the ability of define the problem. There is a first step. And another approach is system engineering approach. Okay, the system engineering approach will give a clear idea about how a problem can be focused on either product or maybe a process or a software. So to develop and build a system based upon the problem you are having. And in a system engineering concept, in the view, it should be more technical, not theoretical. System thinking may have theory, and system engineering must be a more technical. So what software we are using, what's the coding technology you are using, and how much data it will consume, and what is the speed. Okay. So more technical. Okay. Then only it is good for is something like that configuration. So specifications, configuration, physical design, system design, architecture of the system design, and finally it ends with production and testing. Okay, it will go for production and it will check for the testing, okay, whether the system is applicable to work in the real world. Okay. Even some of the commercial products and military sectors also it is being more evident for checking the physical design and testing also. Okay. Every time you can see in every country, so launching or testing atomic bomb or maybe a missile launch, every time they will test how many kilometers the missile is traveling, maybe 1,000 or 2,000 or one location to another location. Okay. And engineering approach. The third step of perspective of system is how it is useful for the society, okay, and how it is make the global impact. Okay. And moreover, it's a social or economic or environment factors. What it covers the social science and management process. Okay. So everything. So because most of the products are created in the healthcare, energy, environment, and information security. So other global issues are there areas for attention. People must work on this engineering system and how we are going to use it in the real world. So first one is system thinking. Second concept is system engineering and engineering system. So this chart will give a clear idea about perspective of engineering. We can compare easily. Okay. So what is system thinking? It is focused on only process. And system engineering focus on only product. And engineering system focus on both process and product. Okay. Any kind of engineering system. We take weather forecasting system or satellite navigation system or a GPS. It will have process and the product. And system thinking only focus on issues. The system engineering and engineering system will focus on how to solve the technical and interdisciplinary technical, social, and management issues. Solve the problem and identify the problem. System thinking is define the problem. And system engineering system is to solve the complex problem. An evaluation of multiple factors and influences. And system engineering will develop the tangible system solution as well policy and process and final solution. And in fourth point of view, system thinking focus on inclusion of patterns, relationship, and common understanding. And system engineering need to meet requirements, measures outcome, and solve problems. An engineering system integrate human and technical domain dynamics and approach. So this is what how we can manage the system engineering concept into different locations. So how the system engineering approach will be there for managing the whole activities. That is called as perspective. The perspective of system always have three major steps: system thinking, system engineering, and engineering system. That's it. Okay. So one is for idea, and another two is for how you implement the idea. So product and process. So domains. So we have multiple domains in the system engineering. So management, engineering, technical is one side, and political, legal, human, social another side. Another side. So this is called a system engineering domain. So these are the domains people are working: the human, social, technical, engineering, management, political, and legal. Six different categories, different domains. So these domains play the vital role to identify how to manage, how engineering will have the influence in human and social, and how it is technical, and how it is influence in political and legal. So these six domains a system engineer must have the knowledge. And system engineering fields. So we have many fields, but system engineering have two major focus. One is management and engineering fields. Okay. So management, if you come to the management, what it does: so operations research, project management, human, HR, quality. So these four play the vital role in the management. And in engineering field, architecture, control system, modeling, and simulation. So totally 7 numbers. So these are the fields. In domain we have 6, and fields we have 7. The system engineering play the important role to identify the solution for the problem which you are having and how you are going to execute in the real world. That's why the fields are playing the major role. So without the fields, you cannot manage. Quality management, HR, financial, these are play the vital. Finance is very important. If you want to go to Mars, you cannot go directly to the Mars. You need finance. You need millions of dollars to invest in the particular technology you are going to use. Okay. And OR operation research provides a qualitative analysis of alternatives and optimal decision. And modeling and simulation provides a cost-effective examination of system option to meet the requirements and needs of the user. Okay. And finally, structure and architecture. So these are the main focus related to the system design and architecture. We saw in the video at the beginning. So these all included in that NASA design. How to set up a home in Mars. These everything is related. Quality, HR, finance, operation, modeling and simulation. We saw only the modeling and simulation. We don't know whether in Mars they have the actual prototype model. So these are the fields. Okay. And approaches. Okay. So approach is, we have the major 4 approach: linear, waterfall, design, spiral diagram. So linear is very simple. So we have to develop a concept, take on project. Maybe your project may be a agriculture land verification. So whether the land is good for cultivation or not. That is a concept you have developed. You have developed on an app, and using that app you can find which area is good for cultivation. Suppose development. Okay. So idea, design, and product development. So similarly, so this is step-by-step execution, linear, and waterfall. So waterfall, how the water will fall from falls or some locations you are going to see. Same location. Okay. How we are going to extract the information. Start from requirement, function, step by step. Okay. Top down approach and bottom up approach. Okay. First one is top down approach. So requirement for developing agriculture land verification and functional definition, physical definition, and design validation. Again, it's going back to the requirement analysis to update your system. Bottom up approach. And another concept is V design. V design also have start from particular location and it's coming to the another stage that is called as implementation. So life cycle process, implementation, and document approval. So 3 stages are there in V design. So problem you are having, how much time it will take to complete your problem, and what you need to complete the problem. Spiral design, everybody know about that in system software engineering. You may study this concept. So it will always start from need analysis. Spiral starts one location and end at one location. Always start from need, followed by mission, function, concept, requirement, design, design system, effective analysis, system integration. Finally, it will go for productability analysis. So this is the ultimate concept behind the system engineering approach. Linear, V design, waterfall, spiral. So when you go to this deeply into the life cycle system engineering view, okay, for a particular design you want to create. So, for example, you want to create a customer relationship model for a air ticket reservation or railway reservation system. First, we have to understand the customer requirement. Okay. So that is called as need analysis. Then concept. Then concept and program definition. Here we will do the pricing, estimation, contract. Okay. Who is going to control the work? Who is going to deliver the work? Okay. Finally, it is connected with the design, technology validation, and engineering development. And it will go to the verification for testing. Once it's come to the delivery, okay. And project is close out and follow up. So these are the step-by-step execution. Customer need to delivery. So customer need is satisfied in the product development, and finally it will go to the warehouse for sales. So this is a typical architecture which is giving clear idea about how a concept can explode and how it is can become product and process. Okay. So these are the major concepts behind how we can manage the system engineering approaches, okay, and the fields, then domains. Okay. Then followed by we have development models. Okay. So these are the some of the few concepts behind the system engineering. So which will give the very good idea to a system engineer, a computer science system engineer. If you want to become a very good computer science system engineer, and definitely you must have the idea of the career development model. You must have the ability to multiplex, and you should ready to take over a challenging problem, and you must understand the big picture of the problem, and you must have the knowledge to solve the complexity of the problem. Okay. So please go and refine. So the reference same The book and PPT is available in our class, Google Class. Please download it, okay, and you can start read. Okay, and yeah, let me take this attendance. Okay, fine. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is not there.